let's see the second method to construct the analytic functions. This method we will call as Milne-Thomson method. That is, this method is known as Milne-Thomson method. In the problems, if they mentioned u is real part, not a harmonic, if they mentioned u is real part, on that time we will use this Milne-Thomson method. We can use this method in the problems if they given u is real part. Write down this real part in the step 1. That is, in the step 1 we have to write down the real part. That is, u we have to write down in the step 1. In the step 2, we have to differentiate u partially with respect to x and partially with respect to y, and put the value of dou u by dou x as phi 1 of x comma y, and put the value of dou u by dou y value as phi 2 of x comma y. After getting phi 1 of x comma y and phi 2 of x comma y values, we have to substitute phi 1 of x comma y and phi 2 of x comma y values in the required analytic function. That is, in the step 3, by Milne-Thomson method, the required analytic function, we have a required analytic function, that is f of z is equals to integral of phi 1 of z comma 0 into dz minus I into integral of phi 2 of z comma 0 into dz plus c. Here we have to substitute phi 1 and phi 2 values by replacing xy as z comma 0, because we are doing the integration with respect to dz. So we have to replace xy as z comma 0, where c is the constant of integration. After simplifying this RHS side, we will get the required analytic function. To solve the problems, these 3 steps are enough. We will get the required analytic function. So these 3 steps are enough to solve the problems, but we should know how to get this formula. See here, suppose we require an analytic function f of z is equals to u plus iv. That means we are considering analytic function f of z is equals to u plus iv. So here do the differentiation with respect to x. We will get differentiation of f of z is f dash of z, that is equals to ux plus I into vx we will get. Then apply the CR equation here. Vx formula is minus uy. That means dou u by dou y equals to minus into vx. So apply here. Then we will get f dash of z is equals to ux minus I into ui. That means we are substituting the CR equations. Then do the integration here. We will get integration of f dash of z is f of z, that is equals to integration of ux. We are getting ux value is phi 1 of x comma y. With respect to dz we are integrating. So we have to replace x comma y by z comma 0. That means we are getting ux value is phi 1 of z comma 0 into dz minus I into integral of uy. We are getting uy value phi 2 of x comma y. So here we have to change phi 2 of x comma y in terms of phi 2 of z comma 0. So replace x comma y as z comma 0. That means we will get uy value phi 2 of z comma 0 into dz plus c. But to do the problems, these 3 steps are enough. See the example. Find the analytic function whose real part is x cube minus 3xy square. See here, real part is given. That means we can apply the method 2. To construct the analytic function, we can apply the second method. So write down the given value. In the step 1, we have to write down the real part u, that equals to x cube minus 3xy square. In the step 2, we have to differentiate u partially with respect to x and partially with respect to y. Do the differentiation. Differentiation of u with respect to x, we will get x cube differentiation 3x square minus x differentiation 1. We will get minus 3y square. Differentiation of u with respect to y, we will get, see, with respect to y, x cube is 0 because we are doing the differentiation with respect to y. So x cube value is 0. Then minus 3xy square, x differentiation. See here minus 3x are constant, y square differentiation 2y, 2 into 3 6, you will get minus 6xy. Then in the step 3 we have to substitute these values in the function f of z, and also we have to mention the value of dou u by dou x as phi 1 of x comma y, and we have to replace, or we have to mention the value of dou u by dou y value as phi 2 of x comma y. Then put in the analytic function, that is the required analytic function by Milne-Thomson method. We required analytic function f of z is equals to integral of phi 1 of z comma 0 into dz minus I into integral of phi 2 of z comma 0 into dz plus c, that equals to integral of phi 1 of z comma 0 we are getting, see, that means we have to replace x by z, then we will get 3z square, minus we have to replace y by 0, we will get 0, that means we are getting phi 1 of z comma 0 as 3z square into dz minus I into integral of pi 2 of z comma 0. Here also we have to replace x by z and y by 0. If I replace y by 0, I will get whole term 0. So substitute here. Then we will get pi 2 of z comma 0 is 0 into dz plus c. Then integration of 3z square is 3 into z cube by 3 plus this term is 0. So write down as it is 0 plus c. Then finally we will get the analytic function. We got the required analytic function f of z is equals to, here 3 get cancelled, z cube plus c. Z cube plus c is the required analytic function.